Hello students, and welcome back to Chemistry A. I'm Ms. Sleight, and today we're going to be talking about ionic compounds and how to write their names and formulas. So first off, why is it that sodium and chlorine will come together to form the compound sodium chloride? To figure this out, we need to look at how the electrons are arranged in both of these elements. So if we look at the electron configuration of sodium, we can see that it has 11 total electrons and 1 valence electron. So its Lewis dot structure has 1 dot on it. When we look at chlorine's electron configuration, we can see that chlorine has 17 total electrons and 7 valence electrons, 2 from the 3s and 5 from the 3p. So its Lewis dot structure has 7 dots around it. Now, how atoms form bonds is governed by something called the octet rule, or the rule of 8. And it's simply the tendency of an atom to gain, lose, or share electrons to have a full valence shell. Meaning that when atoms come together to form bonds, all of the atoms want to have their outermost energy level completely filled with electrons. So if we look at sodium, it has just 1 electron in its 3s. So if we're to lose that 1 electron, its second energy level is now full. Chlorine, on the other hand, is only missing 1 electron from its 3p. If it were to gain an electron, it would now have a full third energy level. So let's kind of see how this works with the dot structures. So we've got sodium and chlorine. Sodium is an alkali metal. It has a very low ionization energy. It's very apt to lose electrons. Chlorine, on the other hand, is a halogen with a high electronegativity, which means when chlorine forms bonds, it's going to very strongly attract electrons. And that's exactly what happens. Sodium loses its 1 valence electron to chlorine, so now they both have full valence shells, and it becomes a sodium +1 ion and a chlorine -1 ion that are attracted together to form the compound. Now let's watch a short clip that shows exactly what this reaction looks like in real life.
Sodium metal is heated until it melts and just begins to burn. Then it is immersed into the yellow-green chlorine gas. The sodium begins to burn in chlorine with an intense yellow flame. It produces the white smoke of sodium chloride. We are observing the exothermic reaction of sodium metal with chlorine gas, producing the white solid sodium chloride. Afterwards, the glass spoon contains only white solid sodium chloride.
Now let's talk about some of the properties of ionic compounds. First off, in ionic compounds, the atoms exchange electrons to form a more stable, lower energy system. And when bonds form, energy is released. The structure of an ionic compound is called a crystal lattice. It's just a repeating pattern of ions. And the positive and negative ions will always arrange themselves in a repeating pattern that balances charges, meaning the final compound will always be neutral. The charges of the ions will add up to 0. And these ionic crystals have very strong, rigid structures to them. Now let's talk about some types of ions. First off, there are cations. They're typically formed by metals. And a cation is just an atom that has lost electrons and has a positive charge, like sodium. On the other hand, there are anions. Anions are ions that have gained electrons and now have a negative charge, like chlorine. Now, the way I remember the difference between these two is that I remember that cations are positive, like a kitty cat. Lastly, the chemical formula for an ionic compound is what's called an empirical formula, or a formula unit, and it represents the simplest whole number ratio of the positive to negative ions in the compound. For example, sodium chloride is a 1-to-1 ratio of sodium and chloride ions. So if we look at this picture here, we can see in the crystal lattice there is more than just two ions. There's more than just one sodium and one chlorine. All of our chlorine atoms are surrounded by and attracted to positive sodiums. All of the sodium ions are surrounded by and attracted to negative chlorides. But this would be almost impossible to represent with a formula. So that's why we always go for the lowest ratio of the ions. So the formula unit is just that simplest repeating pattern that you'll see in the crystal lattice. So naming compounds. Why do we call a sodium atom bonded to a chlorine atom sodium chloride? In order to have a common language to talk about chemical compounds, scientists developed a series of rules so that everyone was naming compounds the same way. And we're going to talk about what those rules are for ionic compounds. First off, there is naming binary ionic compounds. A binary ionic compound is an ionic compound made of just two elements. And when you name it, you're going to name the positive cation using the element's full name. And then you're going to name the negative ion. And all you're going to do is change the ending of that second element, the negative one, to IDE. So sodium and chlorine come together and form sodium chloride. Calcium and bromine come together to form calcium bromide, etc. Now, naming transition metals gets a little bit trickier because of the fact that transition metals can form multiple ions. So we need a way to differentiate between the various ions that a particular transition metal can form. And there's two ways that this is done. The first way is with the stock system. And the stock system simply uses Roman numerals to represent the charge. So you can see in the first one, when copper has a positive 1 charge, the name is copper 1. When copper has a positive 2 charge, the name is copper 2. The stock system is very straightforward. It's the most commonly used system now. However, you will also sometimes still see the traditional system used, where all they do is they change the ending of the metal's name based on whether it has a higher or a lower charge. So the metal ion with a higher charge will have the suffix ic, and the metal with a lower charge will have the suffix ous. So if you look at the second, the third, and fourth examples up there, we have an iron with a +2 charge and an iron with a +3. So the higher charge in the traditional name is called ferric oxide, and the lower charge in the traditional name is called ferrous oxide. Now the reason they're using ferric and ferrous is because they're using the root of iron's Latin name, which is where its symbol Fe comes from. Now you will find these traditional names all listed on your ion table, which you will always be able to use on tests and the exam. Next up, we have ternary ionic compounds. And a ternary ionic compound is one that involves more than two elements. And typically that means you have a metal combining with what's called a polyatomic ion. Now, a polyatomic ion is just an ion that's composed of more than one atom. To name these type of compounds, first you use the positive ion's full name, just like always, and then you tack on the name of the polyatomic ion. So looking at our first example, we have Na positive 1, that's sodium, and then C2H3O2 negative 1. The name of that ion is acetate, so the compound's name is sodium acetate. On that same little ion table paper that you have the traditional names for transition metals, you will also find a list of the most common polyatomic ions. So you'll be able to look up their names on there as well. Now let's talk about a specific type of polyatomic ion called an oxyanion. An oxyanion is just a polyatomic ion formed from one element combining with oxygens. And they have a little bit of a pattern for them, so let's try and figure it out. Here we have some oxyanions of chlorine. If we look, they all contain one atom of chlorine. They all have a -1 charge, but they have different numbers of oxygen. You can also see that in their molecular shapes. Now, let's look at their names. ClO is called hypochlorite, ClO2 chlorite, ClO3 chlorate, and ClO4 perchlorate. Another thing they all have in common is they all have the root of chlorine, chlor, in their name. Let's look at the combination of nitrogen and oxygen. There's NO2 and NO3. They both have a -1 charge. NO2 has less oxygen. NO3 has more. NO2 has the name nitrite. Oxygen has the name nitrate. The ending of an oxyanion will change depending on how many oxygens are in its formula. So an oxyanion, again, it's a polyatomic ion composed of an element bonded with one or more oxygens. And when we're naming them, the prefix hypo means that it has one less oxygen atom than the ite ion. The suffix ite means it has one less oxygen atom than the ate ion. The suffix ate means it has one more oxygen than the ite ion. And the suffix per means one more oxygen atom than the ate ion. So let's look at an example here. We've got PO3 -3 and PO4 -3. Take a minute to see if you can write the names for these. All right, let's see how you did. PO3 or PO4 has more oxygen, so it is phosphate. PO3 has one less oxygen, so it's phosphite. Let's also look at bromine and oxygen as an example. Take a minute and see if you can write the names for these 4 oxyanions. All right, so BRO, it has the fewest number of oxygens, so it is hypobromite. BRO2 has one more oxygen, so it's just bromite. BRO3, one additional oxygen, makes it bromate. And then BRO4, with 4 oxygens, makes it perbromate. Halogens can form 4 different oxyanions. So halogens are where you're going to see the hypo and the per prefixes. Most other things, you're just going to see an ite and an ate version.
Now let's talk about how we write the formulas for ionic compounds. The first thing you're going to want to do is determine the symbol and charge of each ion. Then figure out what the lowest ratio of ions is that's going to give you a neutral compound, meaning that the charges of the ions will add up to be 0. Lastly, we're going to write the chemical formula using subscripts to represent that ratio of ions. So let me show you what we mean here. So first off, strontium has 2 valence electrons, so it's going to lose those to form a +2 ion. Sulfide has 6 valence electrons, so it's going to gain 2 to form a -2 ion. Now when we look at this, +2 plus -2 will add up to 0, which means it already forms a neutral compound with just a 1-to-1 ratio. So we're just going to write it as SRS, a 1-to-1 ratio of strontium to sulfide. Let's look at sodium next. Sodium has 1 valence electron. It's going to lose that to form a +1 ion. Nitride, on the other hand, has 5 valence electrons, so it's going to gain 3 to form a -3 ion. Now, +1 plus -3 does not add up to 0. We're going to need additional sodiums. So now, if I have 3 sodiums, I have a total positive charge of +3, which will cancel with the -3. Now, the way I write this then is I write Na with a subscript 3 because I have 3 sodium ions, and then just an N for nitride because I only have 1 of them. Next up is calcium phosphide. Calcium has 2 valence electrons that it will lose to form a +2 ion. Phosphide, like nitride, has 5 valence electrons that it will lose to form a -3 ion. Now, it might not be super apparent how we're going to get these to balance, but if you keep adding ions to either the positive or the negative, you'll eventually reach a point where they balance. Alternatively, you can ask yourself, what is the lowest common multiple between 2 and 3? Well, the answer to that is 6. So that means I need a total positive charge of +6, which would require me to have 3 calcium ions, and I need a total negative charge of -6, which would require me to have 2 phosphide ions. So now I have 3 calcium ions, so I'd make it Ca3. I have 2 phosphide ions, so I'd make it P2. Next up, we have barium nitrate. Barium has 2 valence electrons. It's going to lose them both to form a +2 ion. Nitrate, ending in ATE, or really any ending other than IDE, is a good clue that this is a polyatomic ion. So you'd need to pull out your ion chart and look for nitrate. You should find that it is NO3 with a -1 charge. Well, this doesn't add up to 0, so we would in fact need another nitrate. Now, when we write this, we have to be really careful. The correct way to write this is Ba parentheses NO3 2. We use the parentheses because we need to designate, or we need to show that we have 2 nitrate ions combining with 1 barium. For example, if I wrote it as BaNO3 2, well, this now looks like I have 1 barium, 1 nitrogen, and 32 oxygen. So that definitely doesn't work. And if I wrote it as BaN2O6, well, this doesn't work either because now this is not the nitrate ion. So if we need to show that we have multiple of a polyatomic ion, we need to put the polyatomic ion in parentheses. Now let's look at our last example, copper 2 sulfate. Remember, the Roman numerals are telling you the charge of the metal. So this means that copper has a +2 charge in this compound. Sulfate, again ATE, that tells us it's a polyatomic ion. So you'd need to look it up on your ion table. You'll find that it is SO4 with a -2 charge. Well, +2 plus -2, that's already neutral, so we can just write this with a 1-to-1 ratio. CuSO4. And that's how you write the formulas for ionic compounds. So that's all we have to talk about with regards to ionic compounds. And I hope you guys have a great rest of your day.